Now let's get to the solving part of today. We are solving systems by using elimination, our new method. Remember, solving a system means that your solution is going to look like a point. So your end goal is going to be an x and a y value written as an ordered pair. So if you need to, on numbers 1 and number 2, where it has the word solution, go ahead and write above that your answer should look like an x and a y value written as an ordered pair. That way we know when we're done, when we know we have our final answer. Now let's look at these steps that they have given us to solve a system by elimination. Step 1 says to line up like terms. And standard form works best for this. AX plus BY equals C. If you notice, number 1 and number 2 are already in standard form. And what it means to be lined up is, are the X's on top of each other? Are the Y's on top of each other? Are the constants on top of each other? So let's look at number 1. The X's are right above each other. The Y terms are right above each other. And the constants are right above each other. So these are already lined up. This is ready to go to solve by elimination. Now step 2 says to multiply, if necessary, one or both equations by a constant to get the opposite coefficients for like terms. Opposite coefficients is what we did up here earlier, where we were finding the opposite term. Okay, so look back at number 1. Are the x's opposite coefficients or are the y's opposite coefficients? Well, the x's are opposite coefficients, so step 2 does not apply here. We don't need to multiply by anything because x and negative x are opposites. Alright, so step 3 says add or subtract the equations together. Okay, so here's what I want you to do. The elimination method is also known as the addition method. So I want you to put a big old plus sign and make it a big addition problem. And now we're going to add the x terms together. So what is a positive x plus a negative x? Well, those are going to cancel out. That's going to be a 0. Okay, now we need to add the y terms. So 3y plus a positive 2y. That equals a positive 5y. And then now we need to add the constants. So go ahead and bring down your equal sign. And now add 17 plus a positive 8. And we get that it is equal to 25. Notice how we no longer have an x and a y, we only have a y term. That means we can get that y by itself and get a value for that y. So let's simplify. Well, we don't need this 0 anymore because 0 won't change the value of our equation. So we're going to bring down 5y equals 25. And now we need to solve that. So divide by 5 on both sides. The 5's cancel out and we get y equals 5. So there's part of our solution. We now have the y value. So plug that into your point. Well, now we need to go and find our missing x value. What do you think we can do to find an x value when we already have a y value? In order to find an x value when we already have a y value, what we need to do is take the y value that we have and plug it in to one of our 2 equations that were given to us at the beginning. Does it matter which of the 2 equations we choose? No. You can choose either one, and either way you will get the same exact x value because together this is a system, and so in order for this to be a solution, it has to be the same x and the same y value. Okay, I'm going to go ahead and choose the first equation just because the x there is already positive, so it'll make it a little easier to solve. So I'm going to bring down the very first equation, and now I'm going to plug in the y value that I found from my first equation. That y value was y equals 5. So I'm going to replace the y in my original equation. So that's going to become x plus 3 times 5 equals 17. Now simplify. 3 times 5 is a positive 15. Bring down your x, bring down your equals 17, and then solve for x. So subtract 15 on both sides. The 15's canceled out. We bring down the x, bring down the equal sign, and 17 minus 15 is 2. So this is now the x value of our solution. So we go back up here, and we put 2 in our x value of our point. So our final answer is 2 for the x value. Let me rewrite that. So our final answer is 2, 5. Alright, so now I want you to try number 2, following the exact same steps. Make sure that your x terms, your y terms, and your constants are all lined up. And look for an opposite coefficient that will cancel out. Then add the 2 equations together. Pause the video, try it on your own, and then press play and see if you got it correct. So here's the worked out solution for number 2. But all the terms were lined up, so I added them together. The x terms canceled out when added together, and we were left with 2y equals 8. When I solved for y, I got that y was equal to 4. And I took that and I plugged that in to my point for the y value. Then I chose an equation and I plugged that y value into an equation, and I chose the second equation this time, just because the y value didn't need to be multiplied by something, so it was a little easier to plug in and solve. So when I plugged that in and I solved for x now, then I got that x was equal to negative 1. And when I found that, I took that and plugged that into my point, and my final answer is negative 1, 4. So that is your solution to your system, the point negative 1, 4. Now on to the back. It says making connections. It says explain in words when solving by elimination will be better to use than the other methods. So when would elimination be better than solving for y and plugging it into the calculator and solving by graphing? And when would it be better instead of taking a value and substituting it into the other equation? So think of that, and then in class I'm going to call on somebody at the very beginning, and I'm going to see what you wrote for this.